Algebra 1, Investigation 3. For this investigation, we are looking at our different surveys that we can take and how bias can make a difference in our sampling surveys and even how we display our information in a bar graph. So first of all, I'll just start reading here with this investigation. To gather complete and accurate information about a particular population, researchers need to collect data from all of the population's members. Sampling. It's not always practical to survey every individual in the population. Think about if you were to try to get information from every single person in your school, how long that would take, or every single person in your city or in your country. It would take a very long time. So researchers use data from the sample to draw conclusions about the entire population. The table below identifies 5 sampling methods. We'll get to that in just a second. Remember these different words that we've seen before. Population is a group that someone is gathering information about. So your school, your city, your country. A sample is just a small part of that population. And a sample is random if every member in the population has an equal chance of being chosen. For example, maybe at your school, everybody gets a ticket that has a number on it and you draw the numbers for the people that are going to be part of the survey. Or maybe you use student ID numbers to get a random sample, something like that. So let's go ahead and look at the different options that we have to sample. Simple random is selecting a group at random from the larger population. So like I was saying, you could take everybody's student IDs and randomly select which people are going to be part of it, or draw names of people from a hat. Something like that would be simple random. Stratified random is separate a population into smaller groups that have certain characteristics, then survey at random within each group. Maybe in your classroom, maybe you separate by hair color or by shoe size, which would be silly, or by gender or something like that, that you can put people in different groups. Their example in the book, separate a herd of cows by breed, or maybe you go to the store and you separate the people that come in by if they have children or not, something like that. Systematic random sampling is after calculating the required sample, survey every nth member, meaning maybe you're watching people come through a doorway at school and every 5th person you ask if you can survey them, or maybe every 10th person or every 7th. So you are counting and randomly selecting that person in that position. Convenience. This is not a great way to do surveys, but it often is the only way to actually get people that will be part of your survey. This is selecting individuals from the population based on easy availability or accessibility. So like my example of going to the grocery store, that's convenient sample because it's convenient that we have many people coming in and out. Or when people stand on the street corner and ask for your opinion on something at a street light. They're there by convenience. Or like their example in the book, survey the first 5 people who arrive at the local mall. Our last type of sampling is voluntary. Sample individuals who self-select into a survey by responding to a general appeal. So like a news program that asks viewers to participate on an online poll, or maybe you get an invitation in the mail to participate in a survey, or a lot of companies put surveys at the bottom of their receipts. That would be a voluntary survey that you are saying, yes, I want to be part of that survey. So let's look at this situation. A luggage company wants to know the most popular backpack color among high school students. Company representatives record the color of backpacks carried by boys in the cafeteria during lunch. Since the survey excludes high school girls, the sample is biased, meaning we are swayed by some choice that the survey made. It does not include some members of the population. So give a reason why the sampling method may be biased. So let's look at each one of these. Number 1, a chef asks the first 4 customers who order the new cheese sauce if they like it. There's a couple different reasons this might be biased. One of them might be that the chef himself is asking the people, the customers who ordered the new cheese sauce. If a chef comes to you and asks if you like it, you might be kind of pressured into saying yes, you like it, rather than someone that is less connected to the actual production of the cheese sauce. So that's one. There's many others. Number 2, at a convention of science teachers, attendees are asked to identify what their favorite subject was in high school. Well, if it's just a convention of science teachers, they might be more likely to say something in the STEM careers, science, technology, engineering, math, rather than if you had all teachers in a room and asking to identify their favorite subject. Number 3, a librarian sends questionnaires about library usage to families with children. So with this one, if you're only surveying families with children, then you might only get information about books that are geared towards younger kids or activities that are geared towards kids. If that's what you're going for in your survey, great. But if you're trying to get a survey of everybody that uses the library, it would be biased in that you're not gaining information from all parts of the population. Okay. So, researchers for an advertising campaign survey people to find out why they like to visit the zoo. Give an example of an unbiased sample for this survey. There's a lot of different ways that you could do an unbiased sample for the survey. Maybe you do something where as people come into the zoo, you randomly select them based on their position in the line. So every 10th person, you ask if you can survey them. Or maybe you collect everybody's phone numbers that enters the zoo and randomly choose the phone numbers that will be part of the survey. There are different ways to randomly select people for the survey. 5, describe a systematic sampling. That's what I mentioned before about choosing every 10th person that comes through the line. Number 6, would it be biased to only survey families with children? Yes and no. Depending on what your survey is, if you want to know why everybody likes to visit the zoo, then yes, it would be biased only to survey families with children. But if you only want responses from those families, then it would be an unbiased study. But most likely it would be a biased study because you want to survey everybody. Occasionally, researchers ask biased questions that force the person being asked to respond with a particular answer. You're kind of being swayed by the question that you were asked. Something like, didn't you eat enough? Uses a negative question, which indicates the person who is being questioned has eaten enough. There are different ways to make questions non-biased, so let's create one biased question and one non-biased for each one of these. So number 7, a restaurant owner polls 10 patrons on whether they enjoyed the chef's special. Well, a biased question would be something like, didn't you like the special? Or if the chef came out and said, you liked my special, right? Those would be biased questions. Non-biased would be maybe something like the owner coming out and saying, on a scale of 1 to 5, how much did you enjoy the special? As much as you can, trying to keep it so that the person that you're surveying is not swayed by your question. I'll let you do number 8. A music store questions 5 customers about their listening habits. Think about a biased and an unbiased question that you could create to figure out more information about these customers. Okay, to finish out this investigation here, we're looking at some ways that we can take our graphs, our data, and show them in biased ways and unbiased ways. So advertisers may accidentally or definitely intentionally present data in a misleading way, trying to sway you to buy their product. That's very possible. Consider these graphs collected. So graph A could be misleading because of this break in the graph, meaning we don't actually start at 0 with this graph, and it ends up showing that it makes it look like we have big differences between our different owners and their favorite pets. Whereas we actually only have 3 amounts difference from our cats to dogs, only 4 from birds to dogs, and only 3 from fish to dogs. So there's not actually that much difference, even though it looks like it's double or triple the amount of how many people like dogs. Our second graph here, it could be misleading because there are no labels on the vertical axis. We have no idea how many people actually responded to this survey. It could be hundreds, it could be tens. We don't actually know. And graph C, this is actually a good graph to represent this data. We start at 0 so that we can see everything, and we actually have these in proportion, meaning they don't actually look like they're twice or triple the size that they should be. So I'll let you do this one for yourself. You can talk to your friends about creating this data. Maybe you text them, maybe you emailing them, asking them about their ideas. So your school district is discussing the possibility of requiring students to wear uniforms. Your class was chosen to select the colors. They will be either blue or white, so those are your choices. Each student should indicate a color preference. So record your results in a table, make a bar graph, draw your axes and label them, of course, and draw your 2 bars, actually showing the number of people who chose that color. That's going to be your unbiased graph. Then create a biased graph, and there's lots of ways to do this. Think about leaving out some different data, maybe not starting your vertical axis at 0, okay? And think about ways that you can create that biased bar graph that gives enough data to know what we're talking about, but could sway a person that looks at it into believing something that may not be true. So lastly, 15, what's the difference between the 2 graphs that you created? All right, so you can end on that, create your data and your bar graphs to show a biased representation and unbiased good representation. Well, I hope this investigation helps with your studying and your homework.